All right, you guys. So in section 11.2, we're going to be talking about permutations, which this kind of goes along the little warm-up we did. And a permutation is an arrangement of things that you would create. So 4 groups will be playing at a concert. If each group will appear only once, how many different orders can the groups be arranged in? So now instead of 3, we have 1, 2, 3 different performers. For the first group to perform, since there's 4 groups to start with, how many choices do I have to pick from? 4. Because I could pick out of these 4, any of those 4 could go first. But since I selected who goes first, how many choices do I have for the second group? 3, because you already chose 1. So then you only have 3 to choose from. Pay attention, Anthony. And then over here, how many do I have to pick for the next one? 2. And what about for the last group? 1. Why don't you guys multiply this, see what you get? What's 4 times 3 times 2 times 1? There's 24 arrangements. So if I made you do that for the warm-up, that'd be a lot of counting if you have 4 groups. Okay? And the numbers keep going up and up the more choices you have to pick from. A permutation is an ordered arrangement of items that occurs when no item is used more than once, and the order makes a difference. So it makes a difference who goes first or who goes last. Like the example that we picked, if you already picked that you want Travis Scott to play last, that limits your arrangement for the first few. So example 1, suppose the 4 groups will be playing at a concert, but the last group to play will be the Rolling Stones. So the way I want you guys to do these problems is if there's 4 groups, there's 4 spots to be choosing. How many ways can you put the concert together? So one thing that's already like predetermined, what has to be in the last spot? The Rolling Stones. So we actually know how many choices we have for this last spot. We are choosing the Rolling Stones, and that's 1 right there. We started with 4 groups, but we already chose Rolling Stones. So how many do I really have to pick from? 3. So for the first spot, now I only have 3 groups to pick from. So I've selected 1 for this, 1 for this. What's my next number? 2. And then, how many do I have left for the third spot? Only 1. So why don't you guys multiply? 3 times 2 times 1 times 1. So it's 6 choices. 6 ways to arrange it so that the Rolling Stones are last. Make sense? Next one. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? So what you want is you want your favorite book to go first, and then you want your least favorite book to go last. So set up 1, 2, 7 spots. As you begin arranging the books, how many books do you have to pick from for the first spot? How many? Well, you're not necessarily like choosing your favorite, but like out of 7 books, if you put 1 here, you have 7 choices to pick from. But for the second spot, how many do you have now? 6, and then 4, 3, 2, and 1. Why don't you guys multiply this, see what you get? What'd you get? 5,040 different arrangements for these books. That's a lot. The product 7 times 6 times 5 times 4 times 3 times 2 times 1 is given a special name. It is called 7 factorial, and you write it with this little exclamation point. So this does not mean 7 very loud, 7 exclamation point, 7. That's not what this means. In math, what this stands for is that you multiply all the numbers that follow 7. So 7 factorial means 7 times 6 times 4 times all the way up to 1. In general, if n is a positive integer, then n factorial, you would not say n exclamation point. That's not what this means. Is the product of all positive integers from n down all the way through 1. Okay? So 1 factorial simply means 1, because it's just 1. 2 factorial means 2 times 1, which is 2. This is 3 times 2 times 1. Please write this out with me. So this would be 4 times 3 times 2 times 1. Figure out what that is. And then for 5, so for this we should have gotten 24. It's 5 times 4 times 3 times 2 times 1, which is... What about 6 factorial? What did you guys get? I want you to grab your calculator. What if I asked you to do 100 factorial? Would that be fun writing it all out? No, because it's 100 times 99 times 98, all the way up to 1. Would it even be fun typing it into your calculator? No. Everybody grab your calculator. Press math. Go over to probability. My calculator is PROB. Yours might be PRB, which stands for probability. And then what's under number 4? It's the exclamation point. So the way to get that factorial function here, you would press, what did I say, 100? Let's do 100. And then press math, go over to probability. Number 4, hit enter, see what you get. What's up, Dale? That was good. He's here. Do you need him now, or can I send him in 5 minutes?
Send him in 5 minutes.
I'll send him after the notes. Yes. Okay. Thanks. Okay, did you guys get, whoa, what happened? Overflow. It's actually too much for the calculator to handle. I'll show you what to do if that happens, because that means that's going to be a huge number, and our calculator does not have enough power to calculate this, which that's how big this number is. It wouldn't actually show up on your thing. So let's try something smaller. Let's try, I don't know, 21 factorial. That's like 21 times 20 times 19 times 18 all the way up. Whoa, even that is too big. These are some big numbers because this means e to the 19. So let's try something small. Let's try 8. And I'll show you what to do with the overflow in just a minute. 40,320. So if you ever go for a job interview and they say, would you like to make 21 factorial dollars? You say yes, because that's huge. 5.1, because this is in scientific notation, so that means 5.1 exponent to the 19, so it has 19 zeros, so this is like billions. That's why. So this is different notation. This is not even regular notation. All right? Please go to the next. I'm going to show you 2 more examples. What do you do when a calculator overflows and you get these huge numbers? So here's just this notation. N factorial is a positive integer, and it's read n factorial, you would not say exclamation point, is the product of all positive integers from n all the way down to 1. 0 factorial, by definition, is 1. Just like something to the 0 exponent is always 1, 0 factorial is just 1. That's a rule. So now, evaluate the following factorial expression without using your calculator. Because if you do this, let's actually just do it on your calculator for the first one. Do you have the alpha y button where you get a fraction? If not, you would just use division. Okay? Jacob, bring your calculator. So it's 8 factorial in the numerator, 5 factorial in the denominator, and you can do it with the division symbol if you don't have the alpha y. Did you get 336? Right? So it gives you the answer. You guys will know the answer right away because you could just use your calculator. But how did the calculator do this? I need you to write this down because you will have to show me what cancels. So What's 8 factorial? Well, that means 8 times 7 times 6. Please write it out with me. And what's 5 factorial? 5 times 4 times 3 times 2 times 1. Now, what the calculator did, it had actually figured out what this is and divided it by whatever this is. But what you could do, what could we cancel? If we have a 5 on top and 5 on the bottom, they cancel. If you have a 4 and a 4, 3 and 3, 2 and 2, 1 and 1, what's the only thing left to multiply? Why don't you guys multiply? 8 times 7 times 6. We get 336. For this next one, if we were to write it all out, I'm going to do it up here. You don't have to list all of them because 26, 25, 24, 23, 22, 21, all the way up to 1. And then down here, it's 21, 20, 19, all the way up to 1. What's going to cancel? Well, the 21 is right there. I just haven't listed. 21 is going to cancel. The 20, the 19. So really, what's left to multiply? 26 through 22. But this one you could do on your calculator and figure out what that is, because it does give you a number. Okay. Why don't you try this one? 500 factorial over 499 factorial. See what happens. Type it in. See what you get. Did you get an overflow? You should get an overflow. This number is way too big because if you start multiplying 500 times 499, because this is what it looks like, 500 times 499 times 498 times 497. You see where I'm going with this? It's going to continue forever. Those are huge numbers. What do we get on the bottom though? 499, 498, 497, so on and so forth. What's going to cancel out? Everything except what? This is your answer. So you guys need to be able to write it out like this because the calculator will give you overflow, and during the quiz you won't be able to come up to me and be like, oh, I got overflow, what do I do? That's what I'm checking. Let's just finish off these two and then we're done. So what do we get on the top here? 4 times 3 times 2 times 1. What do we get on the bottom? 5 times 4 times 3 times 2 times 1. What ends up canceling? The 4 with the 4, 3 with the 3, 2 with the 2, 1 with the 1. What do we have left? But where's the 5? It's 1/5 because the 5 was in the denominator. So it's 1 on the top and 5 on the bottom. Last one. What's going to cancel? This one is 10 times 9 all the way up to 1. This is 13 times 12 times 11 times 10. What's going to cancel here? Everything after 11. So we have 1 over, what's 13 times 12 times 11? It's 1,716 as your answer. Okay, I'm going to stop right here. Tomorrow we're going to finish up section 11-2. You do have homework. Please find your worksheet, 11-1 worksheet. This packet, that's your practice packet. Your homework is 11-2, numbers 1, 2, 3, 4, 5, 6. I will be giving out stickers tomorrow. Okay, by the end of this packet, the more stickers you get, the bigger reward you get. So I have all these cute stickers. Watch this. I have smiley faces. I have stars. I have these very, very cute motivational ones. Like cute Cute, cute stickers. The more stickers. Now, one last thing, you guys. So that's your homework. I will be checking this tomorrow. However, I did not assign this, but section 11.1 must be finished by Friday. So page 1 and 2, if you have time today, you should work on it. If not, then tomorrow, but by Friday, page 1 and 2 must be finished. All right?